All right, thank you everyone for your patience. We can go ahead and begin today. I want to thank you all for taking the time to attend our webinar, Open Your Eyes, Solving Signal Integrity and Mechanical Challenges in Optical Components and Systems. We hope you'll find today's 30-minute session helpful in aiding some of the design, test, and implementation challenges of optical systems and optical components. I do want to just go over a bit of housekeeping. We have all attendees on mute, so please submit your questions via the questions box, and we'll do our best to answer questions during the Q&A session at the end of the presentation if we have time. If not, rest assured we will get back to you. Someone will reach out to you to answer all of your questions. We've uploaded an optical products data sheet that you can download at any time from the handout section of the panel. So if you want to learn more about our products, feel free to download that data sheet. And at the conclusion of the survey of this webinar today, you'll be asked to take a short survey. This helps us gather feedback on how to improve our future webinars and webinar content. Lastly, we're aware that many of you are taking time from work right now, so we'll do our best to keep this session to the time allotted. With that said, I do want to introduce your presenters today, us as your presenters. My name here is Nat Stevens. I'm the marketing manager with Arden Concepts.
And I'm also here. I'm Steve Castaldi. I'm the lead applications engineer at Arden Concepts, so some of you may actually see me in the field, and I look forward to it.
Great, thanks, Stephen. So a brief agenda of our presentation today. We're going to take a look at the company profile. So who is Arden Concepts? What do we make? What do we do? Why should you care? We'll take a quick review of the current landscape of interconnects and components within that landscape. We'll take a look at some of the design and development of optical components and the challenges that are faced by engineers and how Arden aims to solve those problems. And then if we have time, as I mentioned, we'll have some time at the end for questions and answers. So a brief Arden Concepts profile review. We were established here in Hampton, New Hampshire in 2003, and we're a leading provider of innovative interfaces at 32 gigabits and 70 gigahertz or above for high-speed electronics. Our core technology is the smallest, fastest, most electrically efficient compression mount connector technology worldwide. So as data rates requirements are increasing, the devices and systems are typically shrinking, and our products are there to deliver superior signal integrity in a dense footprint that's reusable across programs to maximize cost savings. So next generation data centers for cloud-based computing applications are rapidly expanding, and the integration of high-speed optical components to meet the bandwidth demand without the corresponding increase of power usage of the infrastructure, like 100 gigabit network capacity is the new normal for server development, with 400G waiting in the wings. And so multiple components must be optimized to work together in the system. And with higher node counts, tighter pitches, and concerns about power consumption pushing the need for better, lower resistance interconnect solution systems, and component designers need to build field service and upgrade options into advanced systems. One area in which there's been a quick and industry-driven innovation has been in the area of optical interconnects. And as the amount of data needing to be transmitted, and this has really driven form factor changes as well as signaling mode changes.
Thanks, Nat. Yeah, so here we have a little bit of a graph up just to give you an idea of the increasing data rates and then some of the normal interconnect systems that have changed as a result of these increasing data rates. So on the y-axis, you can see data rates, and in the x-axis, if you will, the development standard and the connectors that are associated with them. So as Nat was saying, in the optical space, as the data rates have been increasing, one area is the connectors that have been changing pretty heavily. So, in the beginning, you have these connectors that are basically passive data over copper cable assemblies. And as the data rates increase, these connector assemblies are starting to get a lot more intricate, and they're basically becoming systems within themselves. And now you're transferring fiber optic, data over fiber, and your receiver ends of these connectors like SFPs, QSFPs, and CSP2s, they start getting a lot more complicated. So in the next slide, we're going to take a little bit of a look at what some of these interconnects might look like and how this relates. So on the left, we have an exploded view of pretty standard SFP, QSFP style module. So on one end, we have the fiber optic cable coming in, and those photons are entered into the TOSAs and ROSAs, which convert that data from the light into the electrical signal that can be transferred to the PCB and then read across the backplane of the system. And on the right, we have a more advanced CFP2 module, and you see there's a lot more components in here. So basically what we're looking at is how the transition from one module to another integrates a lot more components in it, and that allows for us to do some more advanced signal processing. So some of the signal processing that we're talking about here may be from NRZ or a PAM4 type modulation to something like a QAM modulation. And obviously what happens is you need to start having integrated coherent receivers in the devices such as the CFP modules to start understanding what's going back and forth between the data transmission. So unlike a QSFP module where arguably the TOSAs and ROSAs are relatively passive, here with the transmit and receive ends of the cable assemblies like a CFP2 module, there has to be some built-in intelligence, and that's where the coherent receivers start coming into play and understanding what modulation scheme is being sent across and then basically how to decode it. And what this results in is increased data rates as well as increased data rates over transmission distance. So, you know, from a short reach platform within a network, you know, where PAM4 may be sufficient enough, once you start getting into metro networks, you may start to turn to CFP modules to start transmitting your data over fiber. So this is all well and good, but you know, we want to talk a little bit about how our technology is going to help reduce problems when you're designing and developing your optical interconnect components. So here is a quick example of one of our two most popular contact technologies. So our contact technology is dual compression, and you can see on the left we have our CR08062 contact, and on the right we have our RCO501 contact. Now, normally in application, one of the ends of the contacts is pressed against the PCB, and the other end is the side that sees the dynamic motion. But the contact is dual compression, which means that it's never actually soldered down. Right now, we're looking at a pretty large exploded view, but these contacts are quite small, so they have a really short electrical length. The other thing that these contacts exhibit is they have a self-wiping motion. So you can see between the two contacts on the left, the lattices swipe against each other, and that produces oxide buildups. And on the right, the coils wipe against each other, which also reduces oxide buildups. So inherently, the system is very durable and has a good electrical performance over its lifetime without any degradation. So an example of that electrical performance that we see in our contacts, we looked at some data through some eye diagrams, and we used the contact that was shown in the prior slide on the left, the CR08062. We deployed that contact at 0.8 millimeter pitch in a normal plastic-style interposer, and this is the data that we were able to portray through it. So basically, it's a very high-speed contact. We're looking here at 28 gigabits per second PAM4 on the left and 28 gigabits per second NRZ on the right. And we're happy to show that the eye diagrams are very clean, the eyes are wide open, low jitter, and you can clearly see what data is being transmitted. This is also without any error correction, and there's no bit error rate detected at this moment. Here is another example of that same contact technology, and we're showing the insertion loss over frequency, and you can see how flat and linear that insertion loss is. And that's what's giving us those really clean eye diagrams as we showed in the slide prior. So again, what does this mean? Open eyes, we're showing no bit error rate out to 32 gigabits per second. And as a result of this, you shouldn't have to do any clock data recovery or retiming. And of course, there's no pre-emphasis or post-emphasis, so there's no signal processing to get the data rates that we're showing across those clean eye diagrams. This can result in lower power transmission, which is really helpful when you're trying to design in your circuits. So looking back at some of the interconnect form factors we talked about before, We want to now take a moment to talk about how Arden provides solutions to test these devices. On the right, we have some examples of the components that might be found in a typical CFD2 module. We have the optical modulator driver, the optical modulator itself, and the coherent receiver. Now, typically, there are some tough engineering constraints, both mechanically and electrically, when trying to design and develop these products. Some of the engineering constraints are shown on the left. So we have fragile, high-speed leads, many of them, up to 32 gigabits plus per lane. And that's going to increase as the data rate transmission needs increase. As such, they fit into these smaller packages. The pitches are quite small, down to 0.4 millimeters, and also decreasing every day. Some of the traditional methods of measurement might include soldering these packages down to a PCB during the validation cycle, which can be time-consuming and opens you up for error. And of course, there are production challenges due to the fragility of the socket itself that's needed to test these. So currently, there are pretty unreliable socket solutions to test these devices. So here's a quick example of what Arden's doing to create some socketing solutions for similar butterfly style, if you will, leaded packages related to those optical modulators and coherent receivers. So on the left, we have a photo of our socket, and you can see that there's a unfinished open-top package, and it's sitting on top of our socket guide plate, and then on top of the PCB. On the right, we have an exploded view of a model to give you an example of what we're looking at here, which I can walk through briefly for you guys. So on the very bottom of the right image, there's the PCB. Just above that, we have the socket guide plate. And then above that, we have the clip-on lever lid that holds the whole assembly together. Now we're going to talk a little bit about what type of design solutions this provides. Now, as it's using our Ardent contact solution, we know it's compression mount. So compression mount, we're saying there's no soldering down. This obviously makes the socket reusable over multiple platforms if you keep the same package style. Also, as a result of being solderless compression mount, it's field replaceable. So if you do have any failures or problems with the socket over time in the field, you can quickly unscrew it from the board and replace it in a matter of minutes and send the socket back to Arden for repair. Using our patented contact set, we're showing up to 32 gigabits plus performance with these sockets. So we're meeting current gen performance required to develop these sockets. With these types of packages, there is a concern for using ESD-safe materials, and as such, we do develop them with that in mind. We're capable up to applications into medium volume production test, which is actually where the socket solution on the left is being used. And one of the key advantages of our design here is on the right, you can see how we carefully guide those fragile leads into contact with our contact technologies. So this, as I said before, can be a problem because in production test environments, you need to assemble this package, test it quickly, and then put it into its final environment without damaging it in between. So we worked hard to develop special guiding channels to make sure that there was no damage done to the package during this process. Some other socketing solutions that we still want to mention and are not forgotten are obviously in optical systems. There are large network ASICs that are being developed and designed. The current trend for these large VGA and LGA socket assemblies, we're seeing a really large number of lead counts. And as a result, these packages tend to be high heat and high power. And of course, high speed. Pitches we're seeing normally down to 0.8 to 1 millimeter typically. And of course, this has kind of been an ongoing thing. It's one of Arden's backbone, it's socketing solutions. So everyone's looking for sockets for VGA and LGA assemblies. And of course, Arden provides that. Here are some of the benefits of Arden's socket solution as related to these types of large packages. So just like before, we're compression mount, which makes us reusable and field replaceable. In this application, with this slightly larger pitch, we're using the contact set, which gives us up to 56 gigabits plus operation. Another key advantage of our socket assembly is the vast temperature range. So again, we know that inside these systems, the temperatures do tend to rise as much as we try to control them. So during engineering design and validation, I know that we like to do some temperature cycling. and our socket assembly is good for a wide range of temperatures. We can be used up to 10,000 cycles, and of course, field repairable, field replaceable. Also, with this really large package size, our lid assembly ensures that the package is pressed flat and the PCB is conformed flat to ensure optimal contact. So it's very reliable and there's no opens. Another way that we're making sure there's not too much force added to the package is through our contact compression force, which on average in these designs is around 25 grams per node, which is pretty industry standard. Here we're showing a lever lid with a heatsink and fan, but there's a multitude of other lid options for budget and application, such as some with holes in the top for thermal forces.
So obviously constraints in optical design are found all throughout the design process, and it's essential for signals from optical ICs or between boards to be transmitted cleanly through different test stages. So when access to multiple high-speed channels are needed in a tight footprint, optical engineers are finding our TR multi-coax connectors to be an ideal assembly for clean transmission lines. So our TR multi-coax delivers superior signal integrity from multiple high-speed digital channels. We offer it in a choice of 20, 40, or 70 gigahertz configurations, and users are able to upgrade the connectors as their bandwidth requirements increase. TR is the highest density high-speed multi-coax connector on the market. The interface is compression mount, just like all of our other technology, which drives lower cost of testing by avoiding the costly solder down components that can't be recovered and encouraging reuse across programs. So again, you're going to see superior signal integrity up to 32 gigabits per second, error-free, and a better long-term repeatability of that connector performance in a solderless system. You're also going to see some space savings over SMAs, which we'll talk a little bit about later. Steven's going to chat with you now about some of the applications in the optical field that this TR multi-coax connector really fits well.
Thanks, Nat. Yeah, so as Nat had mentioned with the TR device, it's got a high-density footprint, and it's got great signal integrity. So here's an example that was deployed at the OFC 2017, and it was shown at the Ethernet Alliance booth. In this example, the Ethernet Alliance booth was trying to demonstrate multi-vendor interoperability of the different network equipment across the current IEEE Ethernet performance standards. Our TR device was chosen and used on one of these breakout host compliance boards as a device to break the signals out from QSFP and SFP modules into other protocol equipment. So it was really imperative that the device used to break out from the SFP and QSFP modules had superior signal integrity. It had to far exceed, actually, the measurement equipment and the generation equipment that was being used here. That way, it couldn't be a weak link in the chain. Also, because of its high density, you can see they were able to pack many footprints in here, which, in an evaluation measurement setup in your own personal labs, is a huge benefit. Now, this is an example we saw out in the field where normally we're actually using some TRs to fix some of the inherent problems with the breakout design, such as this. What we're looking at right now is a breakout board of a QSFP double density, which was being demoed at 400G. Now, traditionally, as you can see, people are breaking out to SMT solder mount technology type 2.92 connectors. In this case, they were field replaceable, meaning they could be screwed down. Obviously, there are some challenges that we can see here. Density is at a premium, and there's many connections, and they're really tight together. Also, with the solder down type connectors, you are opening yourself again up to failure because you can have poor solder joints, and you may be chasing a solder failure when you're trying to debug a certain line. Using the field replaceable style connectors as we are in this example, they are often designed to be used once, and as such, when you screw them down to the board, you can move the center pin, which will cause connector failure. If you are using solder down connectors, there is the cost of leave behinds unless you try to recover them, but recovering them can be a timely process, and most people just assume them a leave behind cost. As a result of having many individual connections too, there's increased connection time within the labs, and time is money. So as I said, this is a prime application for a TR device could be used, and we're going to show you through a little graphic of how that might happen. So we've now just highlighted the area of all the 2.92 connectors to give you a rough idea of what that area the TR may replace. And now we're going to show you how the TR can now be used in place of that. So now you can see that TR is taking up all 16 of those channels in a much smaller footprint area, requiring only 2 screws to attach it to the board, and that's it. Now, because it's compression mount, this can be reused over and over again, up to 1,000 cycles with the TR device. You have up to an 80% space savings over typical 2.92 SMA connectors. As a result of these space savings, you can get much closer to the device under test, in this case, the QSFP double D. With the TR device, it can be used up and beyond 32 gigabits per second. Normally, we spec the TR device up to 70 gigahertz, but with different signaling modulations, it may mean something different for you with your data rates. And of course, now without using any push-in connectors, there'll be no failing of those snap-in connectors. Sometimes I see customers, to try to reduce density, may use an SMP or a WSMP style connector, and those can break pretty easily, and they're kind of killer on the fingers. So what does that measurement data look like if I was to use a TR device? Well, here we're running some pretty high data rates through that TR device. This is for a single lane, and we're looking at 56 gigabits, both NRZ and PAM4. Now, the TR device is being used in applications into some of the QAM, as high as QAM 64 scenario modulations. But as this is a typical application we thought we'd show, again, we have very clean and clearly opened eyes, good eye width and height, no intersymbol interference, which means no jitter. And this is a result of really impressive insertion loss and return loss. What we're looking at here is actually the insertion loss and return loss through the TR device itself, which uses our compliant thin contact technology, 6 inches of a high-speed, high-fidelity coaxial cable, and high-quality 1.85 millimeter connectors. So you can understand that when you're doing design and development and validation of next-gen product technology, why it's going to be imperative to have high-fidelity equipment, such as the TR device, when you're connecting from your device under test to your instruments. So the summary that we have here on how Arden supports optical development and the takeaways today that we hope you have, Arden has a focus on signal integrity. So we're passionate about high performance, and we're dedicated to improving the data rates of even the most advanced programs and systems. We care about bandwidth, and we have the data to back it up. All of our data that we show is measured data, not simulated. Our patented contact technology is allowing communications companies today to push their components and systems to 400G and eventually beyond. Our compression mount technology goes into all of our products, and it's based on that technology that we're enabling more reliable and electrically repeatable performance over time and across programs. Our compression products allow customers to be agile in changing their designs without having to scrap entire projects and printed circuit boards with components soldered to the board. This leads to enhanced flexibility and cost savings. This know-how comes from our IP portfolio, where we have over 20 US patents that allow us to make the smallest, fastest, most electrically efficient products. Our products are currently designed into applications and systems of the largest optical communications companies worldwide. So our products are proven in the industry. And we're leading the charge in pushing connector bandwidth boundaries through continued engineering and IP development. So as you strive to achieve 400 gig and faster speeds, Arden's product portfolio will be there to support you from design through test and out to production. And with that said, we thought we'd open the floor up to some questions. Let me go ahead and see what questions we've had formulated here. That concludes our presentation segment of the webinar today. And so we'll take a look at that chat box to see which questions have come through. If your question doesn't get asked or answered in today's segment, we will have someone from Arden follow up with you directly. So let me just go ahead and take a look here. So it looks like one question we had that came through was regarding the TR measurement data and how was our measurement data taken for the TR? Yeah, thanks for this question. Unfortunately, we don't have a graphic up for it, but I will try to give my best to describe it a bit. Up on the screen right now, we're looking at the Arden Concepts product, and in the second image, we're actually looking at the TR device itself. So as I mentioned, that's the TR block assembly, and we included 6 inches of cable plus a 1.85 millimeter connector. So what we were able to do was, actually using another TR device, we were able to design a special test fixture that could bolt right to the end of one of a current TR device, and we can de-embed right up to the reference plane on the compliance pin of the TR. Then using a port extension, we moved the reference plane to the 1.85 millimeter connector of that measurement TR, and thus we were able to obtain those through measurements from the 1.85 millimeter connector to the TR interface.
Okay, great. Thank you, Stephen. And I'm sure we have a diagram of that as well, so should you require a diagram to see kind of how that's set up, we could be happy to send that out to you as well. Looks like another question we have, can you explain on the gold box socket a little bit more about how it guides the pin?
Yeah, sure. After the webinar, I do think we make these slides available to our attendees, so we can look back at that as reference of what we're talking about here. So one of the things is we did use some more advanced materials. So there was concern that this was a medium volume production environment to make sure that the guiding of the leads didn't cause any wear of those guide channels, which could have put foreign object debris into the measurement system and reduced signal integrity over time. So we did look at some really advanced engineering plastics to make sure that wear wasn't an issue. Also, we were looking to have something with a low coefficient of friction so it would guide the leads in without bending them. And we went through many iterations, and there was a lot of mechanical engineering design that went behind that. So, you know, in the title of this webinar, we talk about mechanical engineering challenges and signal integrity engineering challenges. And that's what Arden strives to show. I mean, signal integrity is our first and foremost passion, but we do have a strong presence of mechanical engineering design to back it up. And we go throughout into the field, and we work together with the customers like that gold box design to make sure that we've approached, analyzed, and tried to solve to the best of the abilities of what the marketplace is looking at for mechanical and signal integrity issues.
Great, thanks, Stephen.
Yes.
It looks like that actually puts us up against our time limit today. As I mentioned, if your question didn't get answered, we will have someone reach out to you to go ahead and take a look at getting that question answered for you. With that said, that's going to conclude today's webinar. We want to thank you for taking the time out of your day to come see our presentation. And please bear in mind, if you have applications where you think Arden might be able to help, feel free to reach out to us at info@ardenconcepts.com or to visit us on our website, ardenconcepts.com. If you have technical questions, please direct them to support@ardenconcepts.com. And we look forward to hearing from you. Thank you very much, everyone.
Thank you.